So let's take a look at Riemann sums. So we have a function. We'll call it x squared plus 2 over the interval 1 to 3. And if you want to find the area of that, we know we could just simply, from 1 to 3, find the integral. But we want to look at a way to approximate the area, just kind of guess what the area is, and that's what Riemann sums allow us to do. So let's take a look at how this works. And we know what this graph looks like. X squared plus 2, go up 2, it's your curve. So 1 to 3. So we want to approximate that area there. And I'll take this graph off and blow that graph up really big for us. So there's our y-axis, x-axis, there's 2, and it does curve out. So 1, 2, 3. I want to space it out because I'm going to do a lot of writing there. So one way we can approximate what the area of this region is, and I'll take this little piece off too because we don't really need that. So one way that we can approximate this is if we drew rectangles under this curve and found the area of each one, just length times width, and added them up for both of these rectangles. That's a Riemann sum. So you divide it up into rectangles, find the area of each rectangle, add it up, and there's your answer. Now this one has 2 rectangles, so we would get a better approximation of the area if we broke it up. If we broke it up into 4 rectangles. Just find the area of each rectangle. We'd get a better approximation if we broke that up into 8 rectangles. So the more rectangles we have, the closer we're going to get to the actual area of the shape. And there's 4 methods that we're going to look at. I'll take some of these rectangles off. That's my 2. So 1, 2, 3. We have a left point rule, okay, where we draw some rectangles and we use the left end points. And we'll explain that as we're working examples. Can you tell what's wrong with this method, why it's not a real reliable method? I mean, just look at all the extra space you got there. You're underestimating your area using the left endpoint rule, right? Okay, well, what if we use the right endpoint rule? Right, there's my curve. If I use right endpoints, and you got those 4 triangles, well, what's wrong with this method? Well, now you're overestimating what the actual area is if you use the right endpoint rule. And just kind of give you a sample of the other methods. One that's a little bit more reliable. And I just drew 3 instead of 4 here. Midpoint. Use what's right in the middle of these x values. The midpoint rule. And probably the most reliable and also most difficult is the trapezoid rule. All right, so there's our curve. And you see if I drew a trapezoid, well, let me start that over. You see if I draw a trapezoid, remember that's what a trapezoid looks like. Like a trapezoid fits just about perfectly under that curve. So if I find the area of each trapezoid, which is 1/2 the 2 bases times the height, that's the area of a trapezoid. But keep in mind when you're doing this, this is base 1, this is base 2, this would be the height if you're doing the trapezoid rule. And real important formula. If you want to get around the trapezoid rule, the right endpoint answer plus the left endpoint answer divided by 2 equals the trapezoid Riemann sum. So there's a neat little formula to keep in mind. So let's work some examples and see how these Riemann sums work out. So I hope you watched the other videos and got some good background information from them. So, and let's add something here. Let's say n is 4, which means I want to have 4 rectangles or 4 subintervals. And we want to use the left-hand endpoint rule for this one. So n is 4. So I want 4 equally spaced rectangles between 1 and 3 of this function x squared plus 2. So how wide, or what's the length, however you want to look at it, what's going to be the length of each rectangle? And the way we do that is we take our interval. If we do 3 minus 1 divided by 4. So there's your formula to find the length or width of each rectangle. So that reduces down to 1/2. So each rectangle is going to have a width of 1/2. And there was 2 right there. So 1, I'll use a different color. We got 1, 1.5, 2, 2.5, and 3. So I can have 4 equally spaced rectangles. So since we're using the left endpoint rule, we go up to the curve, go over. You don't really have to know how to draw these. Just kind of know how to make them work. And there's my 4 rectangles. Okay. Now let's find the area of each one. Well, I know the length or width is 1/2. And then how do I find the height? Well, we take the number and plug it into the function. So that's what, 3? So there's the area of that one, plus this is 1.5. Plug 1.5 into the function to get how high that rectangle is, and we still know the width is 1/2. 1.5 squared plus 2, I'll just give you the fraction. Next, 2. So we got a width of 1/2 and a height of be 6 plus 1/2, and this is 2.5 here. And 2.5 squared plus 2 would be 35 over 4. And I think I'm running out of room. So 1/2 times 35 over 4. And then you just add all those up. And you should get an answer of 43 over 4, or any equivalent decimal to that. And notice the 4 numbers we use were the leftmost 4 numbers, right? So there's an example of the left endpoint rule. Now let me take a lot of this off, and I'll show you how the right endpoint rule works. Okay, so this example, we're doing the right endpoint rule. All right, same stuff, 1 to 3. Still n is 4. Everything's the same. I'm just changing the rule. So we still got that 1.5. And we still got 2.5. And we want to use the right endpoint rule. So we're using these right most points. And again, not have to worry about the picture so much. Just know how to do that. And right in there, I didn't draw a very good picture of this at all. But the right endpoint rule, we're going to use the rightmost points. So we're not going to use the 1 here. So a lot of this is just repetitive of the problem we just did. We know the width of each rectangle is still 1/2. And you put the 1.5 in, you get the 17 over 4. 1/2. We're finding the area of this one now. So the right endpoint of that rectangle is 2 plus 1/2. Let's put the 2.5 in and get the 33 over 4. And then 1/2 times the new number. 3 is the right endpoint of this last rectangle. So we put the 3 in there, we get 11. and then just add each one up, multiply 1/2 times 17.4 and so forth, and add it up, and that would be an approximation of the area using the right endpoint rule. And like I said, if you want to do the trapezoid, take the answer we got from the left endpoints plus the answer we got just now from the right endpoints, divide it by 2. That would be the area of the trapezoid. So now let me show you how the midpoint works. Okay, so now we're going to do the midpoint Riemann sum. And I'll draw that same curve again. Maybe a little bit bigger this time, a little more spaced out. So there's 1. 3's way over here. 2 right in the middle. So let's approximate using a midpoint Riemann sum. And we know that it's still 4. N is still 4. So we know we got our 1.5 and our 2.5. So this is the first rectangle. What's in the middle? What's in the middle of 1 and 1.5? That's the number you're going to plug into the function, and that would be the height of your rectangle. We know the width is still 1/2, right? So 1/2, get the number in the middle of 1 and 1.5, plug it into the function, and that would be the height of the rectangle, plus 1/2. Get the number that's halfway between 1.5 and 2. Plug that into the function, and that would be the height of that rectangle, and so forth and so forth. And if you do this midpoint Riemann sum correctly, you should get 12.625. So try that out, see if that works for you. Let me know if I can do anything else to clear this up.